is Devasis. So, in the previous session, we learned up to this, up to the reference variable type conversion. In the reference variable type conversion, particularly the compatible types and how we are going to do in which condition we are doing the type conversion in case of reference. We learned those things. So today we are going to learn types of reference type conversion. Okay, size is much bigger. This will be good. Reference type conversion. So what are the types for reference type conversion? There are two types. Like we saw in case of primitive, here also the same is there. One is upcasting, one is downcasting. Like automatic conversion is there, or like upcasting. Like we are going in the primitive types, like from byte to short, short to char to long, char to int to long, like those things. Here also going from subclass to superclass, assigning a subclass object to a superclass object, that is upcasting. So downcasting is we have like a object will be there of subclass, and we assign that same class like in the case of downcasting, a object is there of the subclass which is being assigned to a superclass. Okay, and so as it is assigned to a superclass reference variable, so the superclass reference variable is holding that, so we know the object is known by the superclass. But when we are when we are going to assign that subclass object to that same class reference variable, so like we are downcasting that one, so we will see that in the example. Okay, like one is casting and another one is downcasting. Okay, the upcasting we tell it as a automatic conversion. We no required to put any cast operator, cast type of things, any type of things we need to do here. It will be automatically casted. It's called implicit, like implicit, and it's like downcasting is like explicit. Okay, so upcasting, it is the implicit type conversion. Okay, in my home now the puja is going on, so you may be hearing that sound. Don't bother, just focus here. The process, the process of storing subclass object reference in superclass reference variable, as I told. Okay, so it is called upcasting. Okay, so let's take a case like there is a class A is there, okay, and class B is there. So if we are going to write like this, A equal to new. So here we are doing what? We are assigning the B object to the A class reference variable. Okay, sorry. So this is called upcasting. So B object is being moved it is subclass, it is being assigned to a superclass. So to a super one, it is being assigned. So it is moved from sub to super. That's why it's called upcasting, going up. Okay. Nothing big deal in it. Hmm. So, and one note is there like it is not possible to store like superclass object in subclass reference variable. Like I already told in the previous session, like it will leads to incompatible time. Like compile time error would be there. Okay. Like I already told in the previous session. In the uh, like if we are going to assign a superclass object to a subclass reference variable, so in the object the memory will be there only for the same class and for its superclass. There will be no memory for the subclass. So as there is no memory, so the reference variable whom it should point in the object, as I told in the previous session. Just go through that previous session, you will understand. It is not possible to store superclass object in reference to it. It leads to incompatible types. Compile type. Okay. Like this, if you do like this, db equal to new, it will lead to that. Okay. So moving forward, we will learn about the downcasting part. Downcasting. It is the explicit. We only the developer will do it. Okay. Explicit reference type conversion will be there. Okay. And it is otherwise known as casting. All these are points. Don't mistake them. Okay. It is known as casting. So here what you do like this retrieving, retrieving subclass object reference from superclass reference variable and storing it in the same subclass reference variable. As I told now. Okay, that is the case. Like we have this example, always go by the example. Don't believe on the statements. Okay, so here it is. As previous statement we have here the B is the subclass of A. So we are assigning the B to A variable and A is the superclass. Okay, so we know that A have the type of B object. We know, we the developer know, but the compiler don't know. Compiler always thinks that this A is holding only A type of object. Compiler thinks that. Compiler never able to see the objects or values. Only JVM can see. So we need to pass through the compiler. Compiler is like a security guard. We need to pass through that. So we need to tell that, yeah, this A reference variable is holding a B type, not a type. So allow this A reference type to be assigned to a B type. Okay, like this we are assigning B, then we should tell that this A type is of a B type. Okay. We should cast here, like we are doing in the primitive. Primitive and reference, no difference. Total same. Just relate these things. Okay. Then it's okay. We can assign like this. Okay. This is called downcasting. So like here, what we are doing is better do like this. It will be a good like while reading it will be the other things. Sorry. Here in casting we are informing compiler that the object is variable is different object. Hence, compiler allows compiling the program. Okay. Hence, compiler allows compiling the program. So it will do this. Okay. This is the check. Okay. So moving forward, like rules in using the cast operator. Everywhere we should follow the rules. Okay. Should know about the rules. Rules in using cast operator. Okay. So what are the rules? Let's see. Like the cast operator type and the source type should have inheritance relation. At first, when we started that reference type conversion, I have told this. Both the cast operator type and the source type like should have inheritance relation, else it leads to compile time error like in inconvertible types. It will give this type of error. Okay, let's take the example like this. Operator type and source type should be should have inheritance relation. Okay, else it leads to compile time error. Why doesn't compile time error? Inconvertible. Okay, like this. So we have here class A is there, okay, and class B is there. which is extends from A. Okay. And we have another class is there, class test. Okay. So if you are going to write like this, A equal to mu B, writing like this, then we are doing the type conversion like we did. Here we are telling that the cast type, it is called the cast operator type. This and inside the parenthesis is called cast operator type, and this is called the source type. Okay, which is coming. It's a B type. It will be okay. So cast operator, this one cast operator is this B. Okay, this B, and the source type is like A, small a. So should have inheritance relations. Okay, B is a type, E J. So they have inheritance relation. So it's possible. This one, it's okay. It's okay. But if we are going like this, so if you are converting this type, here. So here what will come? The compiler will see that test and A type. A type means is A class. These two, test and A, these two have no relation is there. Okay, no relation. A and test. A and test. No relation is there, but we are doing the casting here. Here the cast operator type is and the source type both have no relation. So this one will give compiled time. Okay, like this. And moving forward. Like I have told that we will learn about one exception that is related to this type conversion or reference type conversion, that is class cast exception. Okay, this exception we'll learn now. Java.lang.class cast exception. Java.lang.class cast exception. I have continuing this. So in casting, the object coming from the source variable, like if it is not compatible with cast operator type. Okay, the object coming from the source variable. Okay, the object coming from the source variable. If it is not this object coming from the source variable, if it is not compatible with the cast operator type, this is the cast operator type. This is the source variable. Okay, if it is not compatible, then JVM will throw class cast exception. Okay. So in casting, compiler cannot identify the object coming from the source variable. Okay, because compiler cannot able to see the object coming. Whatever the object is coming, it will cannot able to see that. Okay, it cannot able to see that one. Okay, whatever the object is coming, the compiler cannot able to see. Compiler only checks about the type. A is of type A. It's okay. Test and A of relation. It's okay. So compiler cannot identify the object coming from the source variable because it's check only source variable type and cast operator type, and those two have a is relation or not. Means there is have a inheritance is not. That only check. When the source variable is superclass type, when the source variable is of superclass type and cast operator is subclass type. Okay, this cast operator is a subclass type, source operator is a superclass type. Compiler always compiles. Okay, but if the object coming, this is important, but if the object coming from the reference variable is a sibling type, object coming from this object coming from is sibling type of cast operator, then the JVM throws class cast exception. So below is the example I have given. So like this is the class A is there and class D is there. Okay. These A and D have no relation is there. Okay. Object obj equal to new A. We can assign any class to the object class. Okay. We can assign any class to the object class because object is the super class of all the classes. So we can able to assign any class to the object class. It's okay to it because this is a subclass, is the superclass. We can able to do this is the upcasting. We call it as upcasting. Okay. So if we are writing like this statement, we are writing that obj and D. So compiler will come obj type, it will check like I have written here. Compiler will check the source type. This is the source type. Source type is object. It's okay. And D, this is the class, the cast operator type. What is the cast operator type? The cast operator type is D type. So it's okay. And D and obj have any easy relation? Yes. Every class is a subclass of object. So D is a subclass of object. So there is easy relation is there. So it's okay. So compiler compiles. But do you think the object coming from the OBJ is visible to compiler? No, it is not visible to compiler. It's only visible to JVM. So JVM will see that the OBJ is giving the object new A, and new A cannot be assigned to D because those two are siblings. Okay, so here the class class exception will come. So compiler will check that D and OBJ have some relation and checks the object type, so it compiles. But the object coming from OBJ is of sibling type, that is D, cast operator type. So it could not be able to cast and it will throw class cast exception. So how can we solve the class cast exception? So to solve the class cast exception, we should use instance of operator. Okay. To solve the class cast exception, we should use instance of operator. Okay. So like it returns the instance of operator will return Boolean value. Okay. It will return Boolean value by checking the source type object with the given class. Okay. It works exactly like cast operator. The cast operator which we are using this, why exactly the working is same, but the only difference is for siblings comparison. Like for siblings comparison, the cast operator will throw class cast exception and instance of operator will give false. Okay, like this. The syntax will be like this. Reference variable will be there in the front, like obj in the previous example. Here the obj is there, and instance of operator will be there. Then the class name will be there. Like these and these two are be checking. Okay, this we will be checking like obj is having a object of D or not. We'll be checking instance means object. Okay, we'll be checking obj will have the object of type D or not. Okay, so here if we're going like this, so object obj is equal to new A. If obj is an instance of D, then only do this casting. But each object obj is containing a object of type D, no. So it will return false, and the casting statement will not be executed. Okay. So what is the rule of instance operator? Okay, so what is the rule of instance operator? The rule of instance operator is source variable type and the class name should have a easy relationship. Else compiler will throw compile time exception in convertible types. It is telling that when we are writing this obj instance of D, so obj and D must have a inheritance relation. Obj and D must have a inheritance relation, or else here only the compiler will give error. Okay, the compile time error will give inconvertible types. Okay, so obj is a superclass because obj type is object. So the superclass of D, it's okay. So it's been compiled here. Okay. If it is superclass of sibling object, then instance of operator returns false. Okay, as we saw there. Instance of operator, it will return false. Okay. If it is if obj is containing a type of D, then it will return true. Then this casting will be happening. Okay. So when we should implement uh, of upcasting and when we should go for downcasting in our project. So in projects, upcasting is implemented to develop loosely coupled runtime polymorphic applications. Okay, in project, upcasting is implemented to develop loosely coupled runtime polymorphism. So this part I will be teaching in very depth In the OOP chapter, in the object-oriented programming chapter, there we will be learning the encapsulation, inheritance, polymorphism, and abstraction. There I will teach this, that is loosely coupled and runtime polymorphic. Okay, there will be two type of polymorphic with their runtime and compile time. I'll be teaching those things like overriding and overloading. All those concepts will be there. So here only just remember like this, in projects, upcasting is implemented to develop loosely coupled runtime polymorphing applications. Means to store all the subclass objects into single reference variable and further to execute the invoked method from different subclasses based on the object stored in the reference variable. Like we will take one superclass object. Okay, we'll take one superclass object. There we can assign the all the subclass objects. Okay, like if we have like in our home we have father and we have also grandfather is there. Okay, like if there will be like a invitation will be there for the grandfather, then automatically the father will be invited, like father's brother will be invited and father's children will be invited, so all will be invited in that same invitation, yes or no? So like that way only here it is telling that. Okay, you will not able to understand fully. Okay, just uh, make it like you are knowing something, just take it like that way. So if we are if we are assigning a subclass. Okay, if we are taking a superclass reference variable, then we can assign any subclass to it. Okay, like that it is telling. That is a requirement in the project. Okay, that is called loosely coupled. Okay, that is loosely coupled. Loosely we can assign able to any subclass to the superclass. Okay. So what is the limitation of upcasting? Okay. In the upcasting, like compiler allows us to invoke only superclass members. In the upcasting, the compiler allows us to invoke only superclass members. We cannot invoke subclass specific members with superclass type variable. Okay, it leads to compile time error, cannot find symbol because compiler checks only variable type but not object stored in the subclass reference variable. It's a big statement. We'll go by the example, then we'll understand the statement. Okay. Let's take a example like class example is there, init method M1 is there, some statement like M1 is printing, and sample is there, which is the subclass of example. So there is one method is there M2 and we are printing M2. Okay. There is one class is there test. Here what we are doing, we are taking the reference variable as the superclass and we are taking the subclass as the object assigned to it. So here the upcasting is happening. Okay. So subclass object is assigned to superclass reference variable. Okay. So when we are calling ex.m1, okay, we are calling ex.m1. So what we are doing in this line? So we are calling the m1 method that is present in ex type. So compiler will search for m1 method in the ex type reference variable. So what is the ex type? That is example type. So compiler will go to example type, will search for the m1 method, it will find it and it will print it m1. It's okay. But in this statement, it's a bit complicated. So in this statement, M2, we are telling compiler to search in EX type. So it will go to example class, it will not find the M2 method here. So it will not go to the subclass. Never it will go. Never. That is not the compiler searching algorithm. Compiler never go to the subclass. Okay, compiler never go to the subclass. But sometimes JVM goes to subclass, but that we will learn in the polymorphism chapter. Okay, that will be like overriding will be there. Okay, runtime polymorphic now we saw that we will get. But here we are not polymorphism is not applicable. Okay, that rule is different. We'll learn later. So here the compiler will never go to this subclass. Compiler never goes. Only JVM goes. But in this case, JVM will not go because it's not satisfying the polymorphing rule. Okay, so it will not able to find the M2 and it will give compile time error. This is the limitation of upcasting. Okay, what is the need of downcasting? So, what is the need? Why we should downcast it? So, as we saw that here, there is the limitation of upcasting is there. To avoid this limitation, we have downcasting. Simple. If we want to solve this, we have a solution. We have downcasting is there. We should implement downcasting to invoke subclass specific member. Subclass specific member. M2 is subclass specific member. If we want to invoke that subclass specific member, because we store subclass object in superclass. Subclass object in superclass. Reference variable. We cannot invoke the subclass specific member using superclass reference variable. Here the reference variable is of superclass, so we cannot able to call the superclass, so you cannot able to call the subclass specific members. Okay, only we can call superclass specific members. Okay, for solving that, we should use the downcasting ones. So here ex.m1 is okay. We are printing m1, so we should downcast like ex. We should, but prior to this, we should write like if EX is instance of sample, then write this statement. It is a good approach. So we'll write this sample S, and we are doing casting here. EX is containing a object of sample, so it is easily converting to sample type, and it is being assigned to sample reference variable. So with the sample reference variable, we can call the M2 method easily, and we can print M2 because EX is containing sample object, na? So it will convert easily. Okay, that is the need of downcast. So one questions always come. Everybody fancy questions come. Everybody those who are learning like other languages like those things. They tell that is Java is a 100% pure object-oriented language. Nobody will ask this question like in the interviews. Okay, but for knowledge purpose, see, is Java is 100% pure object-oriented? Object-oriented means what? Object-oriented means implementing the real world things, implementing the real world things in the programming language. It's called object-oriented. Okay, so we have the primitive types is there like int, float. Does int and float is there in the real world? We will go to the market and we will tell, give me 5 int, and he will stare at our face. What this person is telling, could able to understand because that is not the real world things. So as we are using those things for the backward compatibility, we are using those things. So Java is not 100% object oriented, but from Java 5 we have auto boxing and auto unboxing is there. That is, we are using one of the wrapper classes. You may have heard that. We will learn that in more depth, and it will be a lot of enjoyment by learning those things. So we have wrapper classes will be there. So these int and double, all those float, then the classes will be there corresponding for that. Int will have integer type, double we have double type, sort we have sort type of class, capital S. So byte we have capital B type of class will be there like this. So after this we can declare that Java is a 100% pure object-oriented language because we are using the primitive as class. Okay. So up to I think we have completed the data types and literal all in depth. And if any queries are there, please mention in the comment. Okay. And all these notes I will share once the Java sessions are completed. Okay. Because if I'll share, you will only go through the notes and then don't go through the videos. Because all the things that I am telling, I'm not writing in the notes. Some things I am also explaining in the videos. So go through the video. Okay. I will share all these notes in the Git and all those problems related to this I will be sharing in the Git. Okay. Just keep practicing. Okay. Thank you for your patience.